example of longitudinal wave is sound. When it's played, the amplitude is wave.
ازيك يا مس؟
اهلا اهلا، ازيك يا وليد؟ عامل ايه؟
الحمد لله. انا دايما بحب ادخل بدري كده عشان اكون منتظم يعني.
سامعاك يا وليد، بتقول ايه؟
عشان اكون منتظم يعني.
I cannot hear you sweetie. ايه؟
اوكي.
مش سامعاك. انت معانا نيو كومر صح؟
يس.
اهلا وسهلا، ازيك؟ Now I can see you. Welcome. Welcome to Green Level. This is your first time to attend, right?
Right. I'm sorry, my English is يعني bad. Not
No,
good.
no, it's okay. No, it's not bad. And we have Wagd. Wagd is a boy also, right? I remember him from the admission. So we have 3 newcomers or more than that?
Miss, هو
more يعني. more.
Okay. Okay, guys. I think now it's time to start. As I said last time, welcome for the newcomers. I hope you will enjoy science sessions with us, inshallah. So let's have a quick review about what we talked about last session. We started with chapter 15, lesson 1, and it talks about waves. Okay, what are waves? So we have two types of waves. I'm gonna start writing. Please, guys, if you have notebook, you must have notebooks with you. So if you do, please start writing after me. Okay, so as I said, we have 2 types of waves. We have more than that, but we just learned about the 2 types last time. We have the transverse wave and guys, can you hear me now?
Yes.
Yes.
My microphone detached,
Yes.
so that's why we lost connection. Anyway, so we have 2 types: transverse wave and the longitudinal wave. Okay, guys. Both of those waves belong to a type of wave that moves only in medium. It needs a matter to move through. We call them mechanical waves. Okay, so as I said, we have lots of waves, lots of types of waves, but we studied about mechanical waves last time. Okay, mechanical waves, and those are the waves that move only through matter? Okay, guys? Okay?
اوكي ماشي.
Okay. So, again, mechanical waves move only through matter. That means they cannot move through vacuum. And vacuum is an empty space that does not include matter. It does not include air, water, or even solid things. Okay? Okay. Mechanical waves, as I said, we have two types of mechanical waves. Okay? We have the transverse waves that move in right angles with the direction of the wave. So, if we consider this is the direction of the wave, I'm sure you guys about my handwriting. Direction of the wave. I'm writing on the smart board, that's why it's a little bit bad writing. Okay, the transverse waves will move in right angles. Okay, this is a right angle, right? If I change the color in here. Okay, that's bad. This is a right angle. Can you see? It's a little bit far. Yeah, the smart board of grade 7 is not working well. Okay, guys? Can you see it now?
Yes.
Yes. This is a right angle, or we can see perpendicular with it. Okay? Or perpendicular with it. Which means that it is moving, you know, in a 90 angle degree with the direction of the wave. Okay? If the wave is moving this way, or in this direction, the wave will move in a right angle with it. Okay? We say it's perpendicular. Perpendicular. Moves in a right angle with the wave direction. Okay? Okay, guys? Are you with me with this point? Do you have any questions? Yeah, like water waves. Water waves, okay, they move in both transverse and longitudinal wave. Okay, but it's a lot, you know, obvious for them to move in the transverse wave that we're talking about, up and down, okay, which means in a right angle. So if we wanted to describe this wave, we'll find that it has high points and low points. Okay, they have names. Let me pick a color for you guys. Okay, so the highest point in a wave is called crest. I'm trying to. Okay. Still not working. I'm sorry, guys, about this. The highest point, as we said, is called crest. It's called crest. Okay, guys? So when I say, what is the highest point of a wave called? We call it crest. Okay? This is the highest point in the wave. And the lowest point in a wave I don't know what's wrong with the smart board. I'm so sorry about this mistake. We call it
Miss, you can write
Fuck.
whatever you want in words.
Yes, and by text. Yes, I know.
Yes.
But you know, it's a lot easier to do it with your handwriting. Okay, guys. So we have again mechanical waves. Okay, they are the waves or the type of waves that move only through matter. Okay, so they need solid, liquid, gas to move through. That's why they cannot move through space, because space is vacuum. This word means empty space. Okay, so mechanical waves cannot move through this empty space. Okay, they only move through matter. We have how many types of mechanical waves? We have transverse wave and longitudinal wave. We just talked about the transverse wave. They are the waves that move in right angle. They move in right angle with the wave direction. We can have another word for right angle. We say it perpendicular. We call it perpendicular. Let me write it down for you here. So perpendicular, guys, means in a right angle. I tried to put space in this word so you can memorize it. Okay, perpendicular means in the right angle. Did you finish this part?
Miss, what is meant by a perpendicular?
Perpendicular, it means in right angle. This word. It's a 90 degrees angle. Like the one in here.
Thanks.
This one. Right angle with the wave direction. يعني if we considered this line I'm drawing in here is the wave direction. يعني الويف هتمشي ناحية اليمين. Okay, the wave will move to the right. Okay? Okay? The wave itself, the shape of the wave, will be in a right angle like this one in here. Do you get it? It will be in a right angle with the wave direction, taking this shape. Okay? That's the big difference between it and the longitudinal wave. The longitudinal waves are the waves that moves in a parallel direction, which means if the wave direction is moving this way, this is the wave direction, okay? Okay? It will move in a parallel shape, which means with the wave, but it moves in shapes called in compressions and rarefactions, which means that the particles, I hope you grade 7 remember this from grade 6, because we studied about this, but you did not know the names of the waves then. So it causes the...
Miss, what is that wave called?
I'm sorry, sweetie, I cannot hear you. What?
What is that wave called?
It's called longitudinal wave.
Longitude. Oh. Okay.
It causes the the particles of the matter to come closer to each other, like in here, and then move their energy to the next part, okay, which will cause the particles to move away from each other. We call it this point where the particles are closer to each other, we call them compressions. Guys, I'm really sorry about my handwriting. I will try to write with text like Walid said, but it's gonna take longer time. That's why I did not want to use text, but let's try this. Okay. Okay, we call them compressions. Okay. And when the particles are away from each other, we call them rarefactions, if you guys remember. Okay. Let me replace the other words in here. Okay, so as I said, perpendicular means right in a right angle. Yes, that's right. Thank you. So guys, please try to finish this one. Because I'm gonna erase this and move to the PowerPoint, so right angle, guys, means 90 degrees, okay? Okay, guys? Okay, but for the perpendicular, I'm sorry, for the longitudinal waves, they move in a parallel, they move parallel with the wave direction, okay? Okay, guys? Did you finish this?
Yes.
We'll have to move now. Now you will understand more with the animations you're going to see right now. So as we said, we're starting with lesson 1. Okay, what are waves? We're learning about what are waves, how do different types of waves make particles and matter move. So as you learned, the transverse wave, they make the particles of the matter move in a right angle, while the longitudinal waves make them move in a parallel direction with it. Let me show you again here. Okay, so guys, again, the particles of the wave will move in a right angle in the transverse wave, which means 90 degrees, or we can say perpendicular with it. And in the longitudinal waves, they will move in a parallel direction, which means they are in the same direction as the wave, itself. Okay? So the first vocabulary we're learning about wave, okay? And it's a disturbance that transfers energy, which means moves the energy from one place to another without transferring the matter itself. What does that mean, without transferring the matter itself? Okay? If we looked closely in this image, you will see a raft with a girl in it, okay? This is a raft in the rest position or the initial position, which means it's not moving, okay? There is no wave affecting this raft, okay? The wave is coming from behind now, okay? When the wave comes, can you see the direction of the wave down there? The wave is moving, lifting the raft upwards, right? Like the transverse wave we just saw. Okay, and it's moving the energy with it, as you can see. When the wave continues, as you can see, the raft will go back to its initial position. Can you see? So the raft itself did not move and change its place. Do you get it? It's the same as the particles of the matter, like the particles of the air will do the same. So that is what it means by without transferring matter. So a wave is a disturbance, okay? Disturbance that transfers energy or moves energy from one place to another without transferring the matter itself, okay? Okay, and of course, as obvious in these pictures, the wave will move from the source away. Will move away from the source, as you can see. Okay? It's not moving toward the source itself. It's moving away. We have, you're learning about two types of waves this year, mechanical waves and electromagnetic waves. The mechanical waves are the waves that can travel only through matter. They can only travel through matter, which means they can travel through solid, liquid, or gas. Because guys, all of you of course know the three states of matter, right? And matter is anything that has mass and takes up space. I hope you all know this point. You must have studied this in grade 3 or 4. So again, a wave that can travel only through matter is called mechanical wave. Like the sound wave, for example. We cannot hear the sounds from space because there is no matter in space. There's no air, water, or solid in space, right? That's why we cannot hear the sounds, from other planets maybe, or the sounds, of the explosions happening on the surface of the sun, because sound is a mechanical wave that cannot travel through vacuum. Okay, guys? This is the word, vacuum. Vacuum here means empty space. Okay? A space that does not include any matter. Okay. So, what it's called for the material in which mechanical waves travel, we call it medium. We call it medium, guys. Okay? This is the material through which the wave moves. The first type of mechanical waves you're studying about is transverse wave, as we learned, and those make the particles move in a right angle. Can you see it? In a right angle, or we can say here, perpendicular to the direction of the wave. Okay? The highest points on the transverse waves are called crests. The lowest are called troughs. This is perfect example of the transverse wave. You can, all of you can try this at home. Okay, attach a rope to your doorknob and try to, you know, hold the other end with your hand and move it up and down, up and down. You will see here that we're having a great picture of the wave. Can you see? So, of course, your hand here is the source of the energy, the source of the energy. So, obviously, the wave will move away from the source, okay? Your hand here is the source of the energy. The wave will move away from it. We're having here this, can you see these dots? Those are the rest possession. Like if you're holding the rope without moving it, it will be in this possession, okay? When you start moving your hands up and down, you will have now high points, we call them crests, or low points, we call them, what do we call the low points, guys? What do we call the lowest point of the on the wave?
Trough.
Troughs, yes. And the highest points are called crests. Okay?
Crest.
Yes. You have to learn about both of those, guys, because after this lesson, inshallah, you are going to learn about the wave properties. Okay? Like the wavelengths and other things. For you to learn about this, you have to know the highest points and the lowest points, the rest possession itself. Okay? So the rest possession here is the possession where there is no energy in it. But when we moved our hands, they started moving up and down this shape. This is a great example of transverse wave, by the way. Can you see that the wave is moving in right angle, in a 90-degree angle? Can you see? Perpendicular to the wave direction. So this is the wave direction. It's perpendicular with it. Okay, so when I say how do particles move in a transverse wave? Does it move in
لسه دخل الثاني.
Guys, can you hear me now?
Yeah.
Yes.
Yes.
We had a lag.
Yes,
Anyway.
yes.
So when I say how do particles move in a transverse wave? So do they move in right angle with it or parallel with the wave?
Right angle.
Yes, thank you. Is this Omar?
لا كريم يس.
كريم.
عمر مش من المدرسة.
كريم والله وحشني والله.
وانت كمان يا مس.
عامل ايه؟ الحمد لله.
الحمد لله كويس.
الحمد لله. Okay, كريم صح. برافو. Perpendicular. برافو عليك. It moves in a perpendicular with the wave, or we can say in a right angle. Let's move to the longitudinal wave. The longitudinal waves are also mechanical waves, which means that they can only move through matter. They cannot move through vacuum. But what is different about longitudinal waves is that they move in parallel. They move parallel to the direction of the wave. Okay? Okay. So they don't have high points and low points like the transverse wave, but they have parts in them where the particles are closer to each other. So we all know this coil string. We all know them. I brought it one time in the class, remember? When you were in grade 6. So this one, when we hold it from the two ends, because we only have 10 minutes till the session's over. So we're holding it from the two ends, as you can see. We'll start moving it. Can you see the direction of the wave here? Can you see? It's moving right and left. While in the transverse wave, if you looked closely, we moved up and down. Do you know now the difference? This is why the transverse waves are in right angles, while the perpendicular waves are parallel to the wave. So this is my hand. Of course, I'm holding my hand still in this side. In the right side, we're holding our hand still. We're not moving it. We're only moving the left side. Okay? So when we start moving the left side, of course, the wave will move away from it. Will move away from the energy source, which is my hand in here. Okay? We'll have some parts where the coils are far from each other and other parts where the coils are closer to each other. Can you see? Guys, can you see this?
Yes.
Yes. The parts
Yes.
of the wave where the particles are closer to each other, we call them compressions. Okay? We call them compressions. While the parts of the wave where the particles are away from each other, as you can see, we call them rarefactions. This coil, guys, represents the particles of air, water, or maybe some solid objects. Okay? So when we are, talking, for example, when we are talking, this is how the air particles move with the sound energy. Okay? So the air particles will move the energy from one particle to the next till it reaches your ear. Now you get it? So this coil, for example, represents the air particles through which the sound moves, for example. Some parts will be away from each other, others will be closer. Can you see that this knob, or can you see this yarn in here? He's putting it for you guys so we can see that this one will not change its position. Okay? Now the energy is moving away, it's moving away, right? Moving away from the energy source. Can you see that this yarn will go back to its initial place? Can you see? When the wave ends, it will go back to its initial place. Can you see? Now it's back to its, we can say rest position, to its beginning position. It did not move. This is another proof that waves do move, through matter, but they do not move the matter itself. Okay? Which means the air particles will not change their position. Okay, guys, do you get this point? Guys, do you get this point?
Yes.
Yes.
So, guys, if the meeting ends, we'll come back again. I'm sorry, this time we'll have to come back again. Okay,
Yes.
just for 5 minutes. Will not be more than that. So, the mechanical waves, of course, as we said, are like sound waves. Okay.
Miss, we join again after this meeting ends.
Yes, when this meeting ends, yes, come back again. We'll see if it works. يعني هنشوف هينفع ولا لا، لان ممكن تكون السيشن اللي بعد كده هي اللي هتبدا. Okay. So as I said, how do particles move in longitudinal waves? They move parallel to the wave direction, as we said. Okay. But in order for the mechanical wave to move, it moves only with vibration, like the sound waves. Okay. What is meant by vibration? It's the back and forth movement. Okay. It could be up and down movement, back and forth movement in the longitudinal wave, or up and down movement in the transverse wave. Okay? Vibration objects are the source of the energy, of course. The vibrating objects are the source of the energy. For example, when I'm talking, the energy source is my vocal cords. ماشي يا دحوج, you want to remote control my screen? Okay, again, as I said, vibrating objects are the source of the energy, like our, vocal cords, اللي هي الأحبال الصوتية بتاعتنا. When we talk, they start vibrating, okay, which will cause the sound to, start moving through the air particles up to your ears and then to your eardrum, which will then vibrate, causing you to hear the sound. Okay, guys? So the vibrating objects are the source of the energy, of course. Okay. There is a very important point. Here my hand is shaking or it's vibrating. If we wanted to talk about it scientifically, it's vibrating up and down, as you can see. Okay. When my hand stops, which means the vibrating stops, we still can see the wave moving, right? Can you see it? The hand
Yes.
here is vibrating up and down, but here it stopped moving. But you still can see the waves keeps traveling through the rope because the vibrations moved from your hands to the rope, and they will not stop until they are finished. Even when the vibration stopped in this position, we still have the vibrations moving through the rope itself. Okay. This is why the wave continues traveling along the rope even after the hand stops moving. Okay, guys? Okay. Here, for example, we're having multiple vibrations. In here, he had only one vibration in this image. In here, we had multiple vibrations. Can you see that it keeps moving even when the hand stops? Because vibrations are moving the energy, and the energy did not end yet until it reaches the other side. Okay. Okay, so there are a lot of types of lots of examples for mechanical waves, like the sound waves. Okay. We also, of course, the sound waves are longitudinal waves. Okay, which means they move in parallel. They move parallel to the wave direction. Okay. They cause compressions and rarefactions through the air particles, for example. Those are the air particles, guys, and this is how they look like when the sound moves through them. Okay. Like pendulum, guys. البندول. فاكرين البندول? The pendulum we did last year. Okay. Inshallah, we will show this for you guys soon. The water waves also are mechanical waves. Of course, they are mechanical waves, but they share both transverse and longitudinal waves. So it's a combination of transverse and longitudinal wave. And the main cause for the ocean waves, for example, or the water away from the shores to move is the wind. Okay, wind is the one responsible for causing the wave to happen through water away from the shore. Okay, the surface of the water. There is another type which is called seismic waves, and those seismic waves cause earthquakes. Okay, those are waves that travel outward, like outside the Earth's surface, causing earthquakes. Okay, so guys, we still have less than a minute, so if this ends, please come back. We'll just talk about electromagnetic waves, and that's it. Okay. Okay, so as I said, electromagnetic waves are another type of wave other than mechanical waves, and those are the waves that travel through vacuum. Those can travel through matter and through vacuum. Okay? They can travel without matter. They do not need matter to travel through. Okay? And they can also travel through matter. So they can travel in both. Okay, guys? Do you get it? Okay. Light, for example, is a great example of electromagnetic wave. Light is